Hello Internet. Today I'm going to be reviewing a couple of toys that I was fortunate enough to even find that they existed. I looked for long enough, and for the longest time the only thing that I was able to find was this. Um, After searching for some more, I found this. And obviously two are different, but their purpose is the same, is to cut the wick, saturate it with solder, as I would, you know, wick the solder from the core, and then the tip becomes saturated. So I need to trim the tip, and to do that, I would normally have to, while keeping my soldering iron, I have to take it out, put it away, grab scissors, make a cut, put scissors away, grab the tip, continue on doing my thing. So what, you may ask? Well, it kind of gets annoying. It's somewhat distracting, and I've always looked for a way to somehow make this process automatic. And what I really want out of this video is that somebody out there could come up with something that works better than any of these two, because both of them lack one particular thing. And I will show you what that particular, or feature rather, it fails to cut in a very specific way that I am after for the most part. So here's how it works. Basically, we're going to power this one on here. This one is by far the most confusing one of them all, and it already failed on me being brand new. And it's very disappointing because, given the fact that this was manufactured, it was designed, manufactured, and shipped from Japan, you would think you're getting a quality, and you got a quality brand. The brand name is recognized for quality and engineering and whatnot. But this thing is kind of worse than that and better at the same time. It's neither one of them are good. Basically, is what I'm saying, and neither one of them were cheap. So let's go and power this thing on. I'll show you how it works. So basically, if we look really, really close, there's like a diode in there of some sort that shoots the beam through this crack, and it enters the diode on the other end through that crack. And basically, once it obstructs, it activates the blades. Okay, and the blade is nothing complicated whatsoever. I'll show you what the blade is. So we pull this one out. I think we just press down and then this whole thing slides out. So, and the blade is none other than a toenail clipper. It's a little bit different than the rest. You can buy a separate. You can buy the insert separate. So when it doles out, that's a good thing that you can buy an insert. Now, not even a month in use, it would already stop cutting. And so a lot of times, not only that it will stop cutting, it will also stop cutting evenly across the entire length of the blade for whatever reason. So what I ended up doing, there's really no way to adjust the tension. So if it stops cutting, it just stops cutting. So what I did is I just inserted a piece of copper shim right here on the left side of the screw. So that basically pushed this blade a little bit further to the right, allowing this one to do its job. So we were to plug it in, and I were to insert my thing. So when I insert it this way, see, nothing happens. I'm inserting it here, nothing happens. I get close, nothing happens. It has to cross that one little crack, which means I always have to start from the top, and this is the maximum length that I can cut, unless I kind of go in on a crooked, which is possible but not very practical. So regardless, we're gonna slide that. And so once you slide that in there, that's basically how this works. Now, originally, this wasn't working that good to begin with, because it would not retract the blades. It would not open the blades. You seeing these blades open is a side effect of my intervention. I went in there and I broke a little thing off of the gear that would push the mechanism, the trigger, and I offset it and I glued it back down onto that same gear. And what that basically allowed me to do is to trigger the off position after the jaws would open. Otherwise, the jaws would always stay closed once the cut is complete. So what happened then is if the blades fail to cut this thing completely, then you get stuck. The jaws are shut. Your wick is stuck inside. There's nothing you can do until you put a finger in here or something. So that was very frustrating. So what I ended up doing is, like I said, broken the piece off the gear, moved it around so that it would not turn off the mechanism when it's closed, but rather allow the mechanism to continue rotating, opening the jaws, and only then triggering the off switch. All right, so there's that. Then we have the catch tray. You're just gonna slide it out. That's okay. Not too difficult to operate. Uh, this thing here, I don't know what the purpose of this is. Completely useless feature. It had a steel plate that would close the gap. Not exactly sure what the purpose of that was. I just threw it away. So this little knob here doesn't really do anything other than just kind of getting in the way. So I don't know what the point of that was. Other than that, it does its thing, especially after I fix that gear. It works a whole lot better, but it's still far, far from ideal. Okay, so let's move this one out of the way, and then we're gonna get back to this guy. This one was the second that one that I just discovered recently. I was only able to find one in China. I'll probably put a link somewhere in the description to this. Uh, I kind of felt cheated when it arrived because it's 3D printed. You can see the layers and whatnot, and in the inside, the whole cutting mechanism, the springing mechanism, it's all aluminum, machined and whatnot, and the motor is there obviously, but the case and certain parts that are built around that whole aluminum rigid body are 3D printed as well. Not that it affects its operation whatsoever, but it's still kind of funny that this whole thing is 3D printed, and so, but that doesn't matter. For the price, I think it cost me almost $200 with because I had to pay the import duties and the shipping. The shipping was about the same as the unit itself, so comes apart relatively easy, nothing too complicated. The reason why it looks so funky is because I took this proximity sensor that was actually hiding. It was sitting right behind the front of the unit, and it was just hiding behind there. And the issue was that every time I would need to activate or deactivate this, is that I would kind of have to have my finger like that close. So I would have to get my cutter in my wick in there, and I just kind of have to either tap or. And the whole thing is just with this proximity sensor so finicky. It's not reliable. It doesn't actuate the mechanism every single time. It doesn't activate it every single time. It doesn't deactivate it every single time. There's no software, there's no firmware that drives this. It's all relay transistor operated. So, and I'm not really sure how it's supposed to work, but it just doesn't seem to work the way that you would expect. So it seems like it works, but until it doesn't, because at some point, sometimes I just can't get this thing to operate at all. What do I mean by that? Let's say I started my day, power this whole thing on, and then I go in and I make a cut, and then it makes the cut, and then, well, perfect example, it just got stuck. I don't know why. So it's not supposed to do that. It's supposed to go up and down, and that's just one issue. Something about the proximity sensor and the whole thing, that the way that the circuit is designed, it's just not very consistent. I do not know why that is. Sometimes it's just, it would work once, and then it would not work ever again until I cycle the power. I don't know why that is. So, but I ended up moving the sensor here, so that way I can, so that way it works better for me, because when it was behind the panel, it wouldn't work the way I wanted it to work. So, but now that it is here, it's actually working a lot better. So I would be coming in like this. And as I keep my hand close to the sensor, it'll continue to cut. And but with the sensor being behind the panel, I would have to be much closer. In this case, I don't have to be that much closer. And it's just a little bit better. Well, there you go. So now it glitched. Oh, it just unglitched. For a second there, it was not. Oh, it doesn't. It's not actuating anymore. See, I got my finger over it, and it's not actuating. I do not know why that is. It just seems like it fails to register things sometimes for whatever reason. I don't know. No, so it just doesn't seem to cut consistently, and that's the biggest issue with this thing. So also, one thing I like to point out is that the whole aluminum, the whole plunger, there's like a rotating, like an O shape object that's attached to the motor shaft that rotates, that actuates the whole uh, plunger mechanism to which the blade is attached that makes the cut. It's all aluminum. So the rotating piece and the whole assembly is aluminum. So what happens when you have aluminum grinding the aluminum? Exactly. It wears out, and it wears out very quickly. It could even get jammed because aluminum is abrasive. And so, to make matters worse, not a single drop of lube inside. So it was just running dry. And yeah. So another thing is, when you're making all of your cuts, they have to go somewhere, right? So in this case, they go to the bottom of the unit, and then we have a little tiny trap door here. This trap door is just kind of sitting there with the magnetic inserts. That's how it's closed. But the funny thing is, if you look inside, there's nothing that contains these chips or the cutoffs. It does not. Nothing keeps them from getting inside of the box anywhere around. See, one just flew down there. Where is it gonna end up? I have no idea. So when I flip this over, shake it out, I can only hope that I got them all out, and I didn't, because some of them got stuck on the edge. See there? And then if the mechanism actuates, it just gets everywhere. See this? So that's a massive problem, especially considering the fact that the circuit that drives this whole thing is exposed, even though it's on the back of the board. But still, it's eventually things could get to the back, and things could short, things could cause problems. It could all of that copper shavings, flux, sticky flux, solder blobs, or what have you, could end up in places where you don't want them to, cause all sorts of damage and whatnot. So clearly, this thing, as good as it may seem at first, it wasn't really thought out. It was not planned very well when they designed this. So, and for almost double the price after shipping and import duties, taxes and whatnot, I don't know if it's worth it. So, but the thing is, basically the main difference between this and this is the activation. This one activates sliding your wick from the top. This one activates sliding the wick from the front. And so my issue with both of them is that when I'm wicking the core, let's say I got this core, right? It's already wicked. And I would probably end up using maybe this much wick. Which one of these, or I could probably get about this long. Which one of these do you think I would use to make the cut? Neither one of them. I cannot make the cut with a wick that long, because if I do this, I am obstructed with the top of the case, cannot insert it there in order to make a straight cut. So I kind of have to either make the cut crooked or something, you know. But then this just kind of dangling here, it's just not ideal for that kind of stuff. I don't know if it's possible to, even using something as simple as a toenail clippers, to design some kind of a mechanism that would allow me to cut this thing from the top like this, or if I were to slide it in without the limitation of the length, like, you know, have an open top. Let me insert this. Let me insert as much wick as I want in here, but also it has to keep the operator safe without the possibility of cutting yourself or whatever. I kind of like both units, but I do not particularly like either one of them. So they both suck one way or another. Neither one of them are perfect. And if I had a choice between one or the other, I would probably go with this because it's a lot cheaper and it's actually manufactured rather than 3D printed. So if you're debating which one to get, I would get this because this one doesn't even work right without modifying, without repositioning the sensor. And even with that, it's just so random. Sometimes it just doesn't want to work for whatever reason. I don't know. Sometimes it works. Most of the time it works, but sometimes, like see right now, I have the finger there, but I just needed a second finger to activate it. I do not know. It's just sketchy, not very reliable. So, well, that's all I have for you today. Hopefully this was educating, and don't forget to like. If you like the video, post a comment below. If you know that there's a better device or any kind of not, even if it isn't better, but something else, I would love to try it. Neither one of these devices seemed to be good enough. This one came with problems, stopped cutting within just the first few days, required me to modify this. Also had to modify the gear in order for the adjust to open properly after each cut instead of staying closed. This one wouldn't even work because the sensor was in the worst place possible, and yeah, so they both suck one way or another, and I really hope someone out there knows a different cutter that I can try. I'll be more than happy to hear your thoughts. Let me know in the comment section. Goodbye.